Hey, whoa, hello everyone. Here is our processing data video. And, okay, let's take a look at what we did. In the last video, you went ahead and grabbed a bunch of random numbers with these means or averages, and we're not concerned with the standard deviation because uh, how variable, how variable these numbers are, it's just very difficult to get the exact variability of the numbers. So at least for now, you'll notice, the formula is here. So I didn't just make up these numbers, but the formula of the averages is right here. And all these averages are equal to the original averages from our experiment. Or not our, but the study that we're trying to emulate. And so now we can safely remove this. And when I say remove, I just mean I'm going to move it down here in case we need it for later. So, okay, I'm gonna drag these numbers up here, and I'm gonna put here the mean. This is this is the mean. This is the standard deviation. SD stands for standard deviation. 95% confidence interval. Standard error of the mean. The count. So the formula is count. You put equal count, and then you select the number, the data set that you want to count, how many numbers there are. There are 12 different numbers for our 12 different participants. Somewhere in here it says that there are 12. Our standard error, I'll show you how to obtain that in a little bit. Our 95% confidence interval, you get it from this formula. If you go back to our t-test, and I'm not sure if it was the ANOVA or... Anyway, at least the t-test does have this formula, but if you're watching this video, well, just go ahead and copy this formula for yourself, and you can just put it here. Once again, all you do is insert these cells. So standard deviation is cell D32. Where is D32? Oh yeah. Oh, I see. I made a small mistake here. Okay. We'll do D20 because that is our new standard deviation. Okay, and then D13. Okay, so everything's good so far. That is our 95% confidence interval. Okay, now our standard error. How do you get your standard error? Well, the formula is a little bit more complicated, and it would take longer to try to explain it than to just do this. Yep, copy that, paste it here. How did I get there? I put the link here in the, anyway, it's the ANOVA analysis. And so we put the link here, and then we calculate. And at least for this mean, and we want to confirm, our mean should be 919. It is 919, it's rounded off. Our standard deviation should be 66.32, great. And our standard error of mean is 19.14. That is the number that I really just went ahead and copied and then pasted onto here. So you can actually go ahead and click and drag. They're all 12. Based on that, you can click and drag. Always confirm. Whoops. Oh, never mind. That is the standard error. That's a number that I copied and pasted. Can I undo? There we go. Then I should be able to click and drag just to confirm. There's our standard deviation, a 95% confidence interval. So we put 0.05 and then our count. And so now what you do is you can copy this in here. And you will get, and just continue doing that for this one and the rest of them. You can add another group. And so you'll get the standard error for all of these groups, for these 1, 2, 3, 4, 5, 6, 7 groups. Now, here, we're not going to go too deep into why, but when we are graphing error bars, we have 3 options. The most basic one, and the one that the lay person, the lay audience or reader will understand, is the standard deviation. It's very easy to explain. It's just saying, look, within this range, about 64% of our data set falls within this range, within this standard deviation. Most people are familiar with that term. However, I would argue that a better representation of the average and the accuracy of the average is the 95% confidence interval. So I would rank them from number 3, meaning the most basic one. I'm ranking them for error bars. So if you want to, what number should you put for the error bars? Rank number 3, standard deviation. Rank number 2, standard error. And rank number 1 is the 95% confidence interval. That's how I would rank them. For this case, man, it's difficult to go with the 95% confidence interval. So only for this case, we're gonna go with the standard error, and that's simply because this is a dry lab, and all of these numbers, well, they were fabricated. They're just fabricated numbers. So it doesn't have a standard distribution. Yeah. So I know all of a sudden I heard myself and I'm like, I sound so negative. But for this case, we would go ahead and use the standard errors as our numbers for our error bars. So once you get all these numbers, we should now be ready to graph. So here are my standard errors. Now, then you may ask, well, why did we do this? In case something goes wrong, we always want to have all these numbers ready. Besides, it gives us another point of, just another talking point, something else that we can discuss along with the range. I would even say, go ahead and include the range. So what's the minimum, what's the maximum, but that can also be kind of derived from the 95% confidence interval and the standard deviation. But I would also suggest, go ahead and take the range of that. I wonder, range, probability, I'll look it up in a little bit. Anyway, we are ready to graph. So you can go ahead and get these numbers. And let's see. I think one good way to do this is to copy these here, and then we'll copy the means. We'll put it right here, special values. We'll take that to 1 decimal, and then we can begin to graph. We'll do a column chart, although, can we separate it? Can we separate it? Well, I'm not gonna go over the whole thing right here, but I think if you play around with some of these things, you should be able to separate them, give them a little bit of space, and then insert the error bars with the standard error. Well, I was testing a couple of things. I think I'm just gonna make a separate video on how to make that graph. So I will see you in the next video. Goodbye, everyone.